In this video, I'll discuss how to find the probability for winning the Powerball jackpot and the probability for winning each one of the smaller prizes, as well as all of the mathematics behind these calculations. First, I'll discuss all of the rules for the Powerball lottery at the 1-minute mark of this video. The probabilities and associated mathematics for winning the multi-million-dollar jackpot begins at 2 minutes and 30 seconds. I'll begin talking about the probability of winning all of the other smaller Powerball lottery prizes after 9 minutes and 15 seconds. If you want to jump ahead to see the probability of winning a certain prize, you will find a link to that section of this video in the comments. Finally, a summary of all of the results of calculating the probabilities of the jackpot and the smaller prizes begins at 19 minutes and 55 seconds. Let's begin with a summary of the rules of the Powerball drawing. In a Powerball drawing, numbers are selected from two separate containers. The first container has 69 balls, numbered 1 through 69. The second container only has 26 balls, numbered 1 through 26. During a Powerball drawing, 5 numbers are selected from the first container. During a Powerball drawing, when a number is selected, it is not returned to the container, so all 5 of these numbers are guaranteed to be different. Then a single Powerball number is drawn. To win the jackpot, you must match all 6 of these numbers. The Powerball jackpot begins at $40 million. It is a progressive jackpot. This means that after each drawing, if no one wins, the jackpot grows. If no one wins the $40 million jackpot, it grows to, say, $53 million, depending on how many tickets are purchased. If no one wins again, the jackpot continues to grow. Now, let's talk about the probability of winning money in a Powerball drawing. If you buy a single Powerball ticket, what is your probability of winning the jackpot? Well, to win the jackpot, you must match both the first 5 numbers and match the Powerball. Therefore, your probability of winning is the probability of matching those first 5 numbers times the probability of matching the Powerball. So to find your total probability of winning the jackpot, you actually have to calculate the probability of matching the first 5 numbers and the probability of matching the Powerball. Once you find those two, they're multiplied together. First, let's calculate the probability of matching the first 5 numbers drawn. It's very important to realize that the order in which those first 5 numbers are drawn does not matter. For example, if your numbers are 1, 2, 3, 4, 5, and the first numbers drawn are 5, 4, 3, 2, 1, you have still matched all 5 numbers. When calculating probability, a selection of items from a collection where order is not important is called a combination. The formula for calculating a combination is usually written like this. In parentheses, there's an n and an r, and the formula is n factorial over r factorial times the quantity of n minus r factorial. This may look a bit complicated, but evaluating combinations requires only multiplication and division. In a combination, n is the number of values to choose from. In a Powerball drawing, the first 5 numbers are drawn from a possible 69 total values, and r are the number of values that are chosen. In this situation, we're choosing 5 values. N equals 69 and r equals 5. In our situation, the combination is 69 choose 5. This would be read aloud. 69 choose 5. There are 69 values to choose from. We're picking 5 of them, and order does not matter. So we will calculate the combination 69 factorial over 5 factorial times the quantity of 69 minus 5 factorial. In the numerator, 69 factorial is 69 times 68 times 67 times 66 times 65. But as you can see, I did not write all of the factors. I stopped at 64 and represented the rest of the factors as 64 factorial. That's because in the denominator, after the 5 factorial, 69 minus 5 is also 64 factorial. These factors of 64 factorial will cancel each other out, and that leaves you with just the 5 factors of 69 times 68 times 67 times 66 times 65 in the numerator, and 5 factorial, 5 times 4 times 3 times 2 times 1, in the denominator. In the numerator, that product is a large number, 1,348,621,560. And in the denominator, the result of 5 times 4 times 3 times 2 times 1 is 120. This quotient is 11,238,513. This means that there are exactly 11,238,513 ways, combinations if you will, that the first 5 numbers can be drawn. So the probability of matching those first 5 numbers, there's only one winning combination, is 1 out of 11,238,513. This does not mean the probability of winning the jackpot is 1 in 11 million. We must also account for the Powerball. The math for determining the probability of matching the Powerball is much simpler. Well, there are 26 possible Powerball numbers. The probability of matching it is 1 in 26. The combination formula can also be used to arrive at this conclusion. The combination 26 choose 1 tells us how many ways there are to choose one Powerball from 26 possible values. In this case, 26 is the value of n in the combination formula, and 1 is the value of r. Using the combination formula, this gives 26 factorial over 26 minus 1 factorial. In the denominator, 26 minus 1 is 25, so that denominator becomes 1 factorial, which is just 1, times 26 minus 1, 25 factorial. And in the numerator, again, instead of writing out all of the factors of 26 factorial, I'll just write 26 times 25 factorial. And the factors of 25 factorial can then cancel, leaving me with just 26. This is telling me that there are 26 ways to choose one value from a possible 26. The probability of matching the Powerball, as we stated earlier, is 1 in 26. So, now that we know the probability of matching the first 5 numbers and we know the probability of matching the Powerball, we can find the total probability for matching the 5 numbers and the Powerball. As stated earlier, this probability is the probability of matching the first 5 numbers times the probability of matching the Powerball. Based on the math we performed earlier, the probability of matching the first 5 numbers is 1 in just over 11.2 million, and the probability of matching the Powerball is 1 in 26. This product is 1 over 292,201,338. This is the probability of winning the Powerball jackpot. In other words, when playing the Powerball, it is highly unlikely that you will hit the jackpot. We can express this probability as a percentage by dividing. 1 divided by 292,201,338, written as a percentage, is 0.000000342%. That is just over 3/10,000,000ths of 1%. Let's now discuss the probability of winning the other, smaller Powerball prizes. In addition to the jackpot, there are 8 other ways to win a prize in Powerball. As you would expect, the more numbers you match, the bigger the prize. Matching 5 numbers without the Powerball wins you $1 million. The prize amounts go down as the numbers matched go down. The smallest prize, awarded for matching only the Powerball, is $4. For the remainder of this video, I will discuss the process to find the probability of winning each one of these smaller prizes. Each of these problems involves using the combination formula in some way. Let's begin. As we discuss the probability for winning the other prizes, I will refer to some of the information that was already presented. Two very important facts that will be used when computing the probability of winning the smaller prizes are the total number of ways the first 5 numbers can be drawn. It's exactly 11,238,513 ways the first 5 numbers can be drawn out of a possible 69. This was found by using the combination 69 choose 5. Another important piece of information we will use as we compute the other probabilities is the total number of ways the Powerball can be drawn, which is 26. If you don't win the jackpot, the next biggest prize is awarded for matching 5 numbers without the Powerball. This will win you $1 million. To find this probability, we will take the probability of matching the first 5 numbers times the probability of not matching the Powerball. We have already determined the probability of matching the first 5 numbers. The probability of matching the first 5 numbers exactly is 1 out of the 11,238,513 possible ways that those first 5 numbers can be drawn. Again, the probability of matching the first 5 numbers is 1 in just over 11.2 million. The probability of not matching the Powerball is 25 out of 26. There are 26 possible Powerball values. 1 of them match and 25 of them do not. The probability of not matching the Powerball is 25 in 26. 25 out of 26. Multiplying these gives a result that's approximately 1 in 11,688,053.52. This is rounded off to 2 decimal places. This is the probability of winning the $1 million prize. If we want to express that as a percentage, we can divide your percent chance of winning the $1 million prize by matching the first 5 numbers without the Powerball is 0.000085%. The next biggest prize can be won by matching 4 of the first 5 numbers drawn with the Powerball. This would earn $50,000. To determine the probability of winning this prize, you must compute first the probability of matching exactly 4 of the first 5 numbers times the probability of matching the Powerball. What we are determining here is the number of ways out of the 11.2 million ways those first 5 numbers can be drawn. How many ways are there to match exactly 4 out of the 5? And then this will be multiplied by the 1 in 26 probability of matching the Powerball. To determine how many ways there are to draw only 4 matching numbers out of the winning 5, where order doesn't matter, we will again use a combination. This would be written as 5 choose 4. There are 5 winning numbers, and we want to find how many possible combinations there are to match 4 of them. Now we will multiply that by the number of ways the remaining number is not a winning number. Of the 69 numbers that are drawn, 5 are winners and 64 are losers. How many ways can you draw one losing number from those 64? Well, there are 64 ways. There are 64 losing numbers. Written as a combination, this would be 64 choose 1. From the 64 losing numbers, how many combinations, how many ways are there to draw one losing number? 64 choose 1. I will now apply the combination formula, which was discussed earlier. The combination 5 choose 4, the number of combinations of choosing 4 out of 5 winning numbers is 5. And the combination 64 choose 1, how many ways can you choose one number out of the losing 64 is 64. Multiplying these gives us 320. This means that out of the 11,238,513 ways, different ways that the first 5 numbers can be drawn, there are 320 ways that you would match exactly 4 out of 5 numbers. The probability of matching 4 out of the first 5 numbers is 320 in 11,238,513. Multiplying this by the probability of matching the Powerball, 1 in 26, gives approximately 1 in 913,129.18. This is the probability of matching 4 numbers with the Powerball. The probability of winning the $50,000 prize is 1 in 913,129. As a percent, this is 0.0001095%. Calculating the probability of matching 4 numbers without the Powerball will be relatively easy because we just did most of the work. The probability to win this $100 prize is calculated by multiplying the probability of matching exactly 4 of the first 5 numbers times the probability of not matching the Powerball. We just determined that of the over 11 million ways the first 5 numbers can be drawn, there are 320 of those ways that match exactly 4 numbers. Then we'll multiply by our probability of not matching the Powerball. Of the 26 numbers to choose from, 25 are not winners. This product reduces to 1 in 36,525.17. This means that you have a 0.002738% chance of winning this prize. This is almost, but not quite, 3,000th of 1%. The mathematics of calculating the probability of matching 3 numbers with the Powerball is very, very similar to calculating the probability of matching 4 numbers in the Powerball, which we already did. First, we will calculate the probability of matching exactly 3 of the first 5 numbers, then multiply that by the probability of matching the Powerball. Again, we are determining how many ways out of the over 11.2 million ways the first 5 numbers can be drawn that 3 numbers are matched out of the 5, and multiplying that by the probability of matching the Powerball, which we know to be 1 in 26. To calculate the probability of matching exactly 3 of the first 5 numbers, we first think about the fact that there are 5 winning numbers. We can choose any combination of 3 of them. This is the combination 5 choose 3. This must be multiplied by the number of combinations that 2 of the numbers drawn do not match. Of the 69 numbers that are drawn, 5 are winners and 64 are losers. How many ways can you draw 2 losing numbers from those 64? That can be determined with the combination 64 choose 2. Applying the combination formula, 5 choose 3 is 5 factorial over 3 factorial times 5 minus 3 factorial. And 64 choose 2 is 64 factorial over 2 factorial times 64 minus 2 factorial. This evaluates to 10. 5 choose 3 evaluates to 10. And 64 choose 2 evaluates to 2016. This product is 20,160. So this means that out of our over 11 million ways the first 5 numbers can be drawn, matching 3 numbers, there are 20,160 ways to match exactly 3 of those 5 numbers. Finally, to determine the total probability of matching exactly 3 numbers and the Powerball, we will multiply this by the probability of matching the Powerball, 1 in 26. This product is approximately 1 in 14,494.11, which is the probability of winning the $100 prize for correctly picking 3 numbers and the Powerball. Your percent chance of winning this prize can be found by division. 1 divided by 14,494.11 is about 0.006899%. We already did the majority of the mathematics to find the probability of matching 3 numbers without the Powerball. This probability can be found by multiplying the probability of matching 3 of the first 5 numbers, which we just found to be 20,160 out of 11,238,513, times the probability of not matching the Powerball. There are 25 out of 26 ways to not match the Powerball. Multiplying and simplifying these two probabilities yields 1 in 579.76. This is a 0.1725% chance of winning. To summarize, you have about a 1 in 580 shot at matching 3 numbers without the Powerball and winning this $7 prize. The calculation to find the probability of matching exactly 2 numbers and the Powerball is similar to the calculations we discussed earlier for matching 4 and 3 numbers and the Powerball. First, we will calculate the probability of matching exactly 2 of the first 5 numbers and multiply that by the probability of matching the Powerball. Using the same approach as our other calculations, remember that we are determining the number of ways out of the over 11.2 million ways the first 5 numbers can be drawn that 2 match, times the 1 in 26 probability that the Powerball matches. To calculate the probability of exactly 2 of the first 5 numbers being drawn matching our numbers, we think about the fact that there are 5 winning numbers. We can choose any combination of 2 of them. This is the combination 5 choose 2. This is multiplied by the number of combinations that 3 of the numbers drawn do not match. Of the total 69 numbers that are drawn first, 5 are winners and 64 are losers. How many ways can you draw 3 losing numbers from those 64 where order does not matter? This can be determined with the combination 64 choose 3. Applying the combination formula 5 choose 2 where n equals 5 and r equals 2, and the combination formula to 64 choose 3 where n is 64 and r equals 3, we get 10 times 41,664. This product is 416,640. So this means that of the 11,238,513 ways that the first 5 numbers can be drawn, the number of ways that exactly 2 can match is 416,640. We're going to multiply that by the number of ways that we can match the Powerball, 1 out of 26. This product simplifies to about 1 in 701.33, which is the probability of winning the $7 prize for correctly picking 2 numbers and the Powerball. Your percent chance of winning this prize can be found by division and moving the decimal place 2 places. It is 0.1426%, which is about 0.15 of 1%. Finding the probability of matching exactly 1 number and matching the Powerball is a very similar problem to the previous probability computations. Here, we must multiply the probability of matching exactly 1 of the first 5 numbers times the probability of matching the Powerball. This will be how many of the over 11.2 million ways there are to draw the first 5 numbers that one match times the 1 in 26 probability we have of matching the Powerball. To calculate the probability of matching exactly one of the first 5 numbers, we again think about the fact that there are 5 winning numbers, and we can choose any combination of one of them to win this prize. This is the combination 5, choose 1. This must be multiplied by the number of combinations that 4 of those numbers drawn do not match. Of the 64 numbers drawn first, 5 winners, 64 are losers. How many ways can you draw 4 losing numbers from those 64? That can be determined with the combination 64 choose 4. Applying the combination formula to 5 choose 1 and 64 choose 4, we get 5, the result of 5 choose 1, times 635,376, the result of 64 choose 4. This product is 3,176,880. This is the number of ways out of the 11.2 million possible ways the first 5 numbers can be drawn that exactly one will match. Multiplying this by the 1 in 26 probability of matching the Powerball and reducing, you get approximately 1 in 91.98. The probability of matching exactly one number with the Powerball and winning the $4 prize. As a percentage, this is just over 1%, 1.0872% chance of winning. The last probability that we will determine is the probability of winning $4 by matching only the Powerball. Finding this probability is a bit more complicated than simply stating that the probability is 1 in 26 because the Powerball is one number chosen from 26. This probability is found by multiplying that probability of matching the Powerball times the probability that none of the first 5 numbers match. Again, in a similar manner to our other calculations, we will determine the number of ways out of the 11 million possible ways to draw the first 5 numbers that 0 of the first 5 numbers match, and then multiply that by the 1 in 26 probability that we have of matching the Powerball. How many ways can we match 0 of the first 5? Well, of the 69 possible numbers, 5 are winners and 64 are losers. We want to know how many combinations of 5 there are of all 64 losing numbers. This is the combination 64 choose 5. Applying the combination formula 64 choose 5 when n is 64 and r is 5, we get 7,624,512. This is the number of ways that 0 of the first 5 numbers will match out of the over 11.2 million ways those first 5 numbers can be drawn. Multiplying this by the 1 in 26 probability of matching the Powerball, we see that there are about 1 in 38.32 probability of not matching any of the first 5 numbers while matching the Powerball. The probability of winning this $4 prize is 1 in 38.32. Performing the division, 1 divided by 38.32, moving the decimal place 2 places, gives you the percent chance of winning this prize. You have a 2.6193% chance of winning this prize. To summarize our findings, we can see on this screen the probability of winning each of the prizes and the percent chance of winning each of the prizes, as well as what that prize is. If you have any questions about the probabilities calculated in this video, please ask in the comments below.